Hello statistics students. This is a video solution to page 383, just checking in your textbook. So a research company is making phone calls and it says that they are able to make contact with 76% of the people. So that means the P is 0.76, and it says they have a list of 12 phone calls to make. So that means the number of trials is 12. So for part A of the problem, we want to know exactly 9 phone calls are successful. So that's the probability that x equals 9. In order to do that on your calculator, we will use the binomial PDF command. And the trials are 12, probability is 0.76, and we want exactly 9 trials. So we would type that into our calculator. And if you do that on your calculator, you will get 0.2573. For part B of the problem, we want at most 9 calls are successful. So I'm going to use that idea that I wrote in the previous problem. So I wrote out 0 to 12. Now what do we want? And when I say at most 9 calls are successful, well, I want 0 all the way up to 9. So this is what I want, and I circled it. So that means I want the probability that x is less than or equal to 9. So on the calculator, I will do binomial. This time I want to use CDF, and I will type in 12.769. And in the previous video, I showed you how to do that. So when we do that on our calculator, you will get 0.5778. Let's take a look at the last example, part C. So in that particular problem, I want to know at least 9 calls are successful. So again, I'm going to write this out to help us visualize this. And when it says at least 9 calls are successful, that means I want 9, 10, 11, or 12. If I say I have at least $9 in my pocket, that means I could have $9 in my pocket. So symbolically, I want the probability that x is greater than or equal to 9. And if you remember from the last video, your calculator will do 0 to 8, and then we're going to have to do 1 minus that. So we will need to type in our calculator binomial CDF 12.768. But because we want 9, 10, 11, and 12, we need to do 1 minus that value. So doing that on your calculator, you will get this to be approximately 6796. So I hope you found this video helpful on calculating binomial probabilities.